All right. Looks like we're about a minute after the hour, so I think we'll go ahead and get started. I know we've got a handful of people that had a watch party and Skoke 100 for this that are really excited about it as well. Um, so again, welcome everyone to another week of our conservation sciences seminar series. Just a few quick reminders that all of you know. You hold the questions till the end or drop them in the chat throughout the talk. We'll get to them in the Q&A after Diego's talk. With that, I'm super excited to have our speaker invited here, Diego Ellis-Soto. So Diego is a Uruguayan PhD candidate in ecology at Yale University and a NASA future investigator. He's currently working at the intersection of ecology, conservation, and environmental justice. He researches how animals move across the world under increasing human threats in a changing climate. In addition, he's increasingly interested in how our access to biodiversity data is shaped by our socioeconomic status and how past and present social inequalities amplify current disparities in environmental sciences. As a music producer, Diego also blends sounds from biological concepts and technologies with music theory, for example, by making 8 termites jam together or installing microphones on an urban farm to make farm birds singing a song. So I think we'll hear some of this today in this talk. Diego received in 2022 the Sidney Manton Award for the Best Review Study in the Journal of Animal Ecology for his work on studying the ecosystem services provided by animals on the move, and the Public Scholar Award in 2023 by the Graduate School of Arts and Sciences at Yale University for his research in shaping public discourse and activism. And with that, I'll turn it over to you, Diego.
Thanks so much, Jack. I really appreciate the invitation. I wish I'd be there in person, and I'm super thrilled to share some of this material, some ongoing work, some recently rejected work that I'm excited to present about. And I'm thrilled to talk about something that I'm more and more interested in the tail end of my PhD, which is on the digital human fingerprint behind these biodiversity records, especially these global big data sets that are increasingly being used to make conservation decisions, and even increasingly conservation investments and large conservation investments. I originally on my PhD, though, study how animals move, how many probably of you in Minnesota, I actually use some of the R package developed at your university from John and others. And in my PhD, primarily what I'm interested is in looking at how animals across the world move, such as depicted here in pink lines. Each line is an individual tracked animal with a GPS tracking device. How animals are tracking environmental conditions, such as snowmelt, for example. Here we can see a global collective of animals moving up the northern hemispheres, but also how various types of human activities are posing a threat or a limitation in how animals can navigate the world. But also, as someone who's increasing interest in where and when we collect biodiversity data, it's interesting that most of these records, for example, in Europe, start at my alma mater at the University of Constance, the Max Planck Institute for Animal Behavior, because the whole world here would be pink, right? But maybe a little bit about me, since this is a grad student seminar, and I'm a grad student, and I'm on the left with the glasses. That's me, and my brother Leo is the big one. So we were holding an anaconda, was probably weighed more than both of us together. And on the right, that's my brother and I at Montevideo Airport, where we would play the flute and ask tourists for money. And without money, we bought those Timon and Pumbaa hats. So I guess I was always meant to do like weird music or scientific communication, depending who the funder is that I want to pitch this project to. But as many of you, how I ended up in conservation or in ecology and evolutionary biology is not trivial. I lived in a bunch of different places. I went to school to a bunch of different places. I started my undergrad in journalism, actually, in Costa Rica, before taking a leap of faith and switching to study environmental sciences in Germany. And I initially hated it. So I took a semester off to work. I scrapped all my savings and working as a DJ at the time to go to the Amazon first and then to the Galapagos, and that interface with biodiversity and high levels of endemisms and colors and sounds really cemented my passion for biology. And ultimately, I worked and did my master in biology in Germany, and I came to the United States at the end to do my PhD. But what might look like a straight line on a CV, like everyone else, is anything but a straight line. It took a lot of twists and turns and random life events that took me here. But yeah, if plants are the lungs of the planet, animals are the veins connecting ecosystems. And in my PhD, a lot of my work is interested in how animal movement is affected by human activities, but also how human activities constraining how animals move might further affect ecosystem services such as nutrient cycle or seed dispersal. But as many of you ultimately, I'm hoping that my research can inform ongoing biodiversity loss across the tree of life. For example, we know that in North America, 30% of all birds have declined across the United States in the last 50 years, and we don't really know why, but we can detect which types of species are thriving and which ones have been in decline. For example, wetland species experience a little bit of a of a positive news, but that was partly because of management action, giving us a message of hope. But all of these big data sets, honing down now to Connecticut, rely on vast amounts of biodiversity data that are generated across the entire country, both in our national parks, but also in our cities, like I will dive into in a little bit. But this is where I'm sitting right now in Connecticut. For example, we have approximately 449 bird species, which is give or take 40% of birds in the United States. But what's really interesting is if we consider the flyway migrations, this is East Rock Park. I don't know if some of you have been to New Haven. There's an urban park right next to my house that has half of all bird species in Connecticut in a urban park close to a big city, 120,000 people. To me, that's a big city, close to a city. So this is also to highlight that nature is not just in the Amazon or in the Galapagos Islands, as all of you know, but also in urban parks or in urban spaces that might have traditionally been considered almost a nuisance places for conservation. And just as a plug, I made a little electronic song called East Rock Calling about East Rock Park that has some beats and music and birds. I think it has some woodpeckers collected at East Rock Park too, if you want to listen to it SoundCloud later. Um, but as I was navigating on my PhD, this is a map that I would see pretty much every day. And how can I collect these large amounts of biodiversity data to make inference on how species are doing under climate change, and then stack those models of species distributions together to then help do conservation decision making. And primarily to achieve these goals 14 and 15 through, for example, the creation of species distribution models, such as we see here, where we mapped the entire clade of hummingbirds, Trochilida, across South America. And these is the typical products that then, for example, would feed into indicators that would tell us how much hummingbirds is each of these countries holding in terms of total biodiversity, how much of the area is Colombia responsible in stewarding. And that's really important because we are almost at a critical position in time. I would like to think that the coming Montreal Biodiversity Agreement, also known as COP15, is almost the Paris Agreement of climate change, but it's a critical moment for biodiversity, where almost every single country except the United States and the world committed to very ambitious conservation targets, among them being 30 by 30, one of the most famous ones. So I feel that these species distribution modeling products that we have been working on in ecology, for example, or habitat connectivity of wildlife, rather than just a scientific enterprise or informing NGO actions, increasingly I see that there's a private sector interest in creating biodiversity products to show that companies are working to achieve these targets, which I think is very much a double-edged sword at the best if we can learn anything from carbon credits and try to not continue this route with biodiversity offsets. That is was at least the underlying motivation among some other factors that led me to pursue the work that I'm hopefully pursuing in the near future, besides my movement ecology work. Um, but human activities, while having ambitious conservation goals near, far, and near, we have more human-made mass than biomass. We have more buildings and infrastructure than trees. And satellite imagery has gone pretty incredible at mapping different types of human activity throughout the world. Um, However, it gets really difficult the more we hone in. For example, in a city environment, half of humans live in cities. 5 billion people more will live in cities by 2030. And the more I think about it, I also think that cities are places where humans experience nature often for the first time, but also on their day to day. And a large proportion of the GDP of conservation decision making is located in cities. So, moving forward, hopefully, I'm increasingly interested in looking at the urban-rural interface and how biodiversity information is collected across a gradient, not just to help guide science and conservation assessments, but also being linked to the bigger picture of civic engagement, social justice, and environmental justice. in cities, as well as educational components to get people out into nature again. But studying how animals share a planet with us, a crowded planet, is not trivial. For example, we know in this landmark study looking at a large number of GPS tracked mammals that with increasing human footprint index, so with increasing intensity of human activities and the amount of people, animals are moving less, mammals. But at the same time, some species are thriving in the Anthropocene. For example, raccoons are increasing their population density with a human footprint index. There are some tipping points, but these are really complex relationships. And during COVID, actually, a bunch of human geographers and ecologists, we got together to almost make a methodological roadmap, both on land, but also on sea, on what we actually mean with human activity, because it's something very different to look at what a satellite image would tell us about land use change than if we were to look at night lights or mountain biking activity on a place or fishing activities or mineral extraction in the ocean. These things really matter. And I would say the COVID pandemic has been one of these life events, both as a human person, but also as a scientist that led me to disentangle. Okay, if we talk about conservation, human wildlife conflict, we should be extremely explicit about what response variable we're actually measuring. And at the same time, when mapping all these different amazing data sets, what something that was increasingly aware that was really hard to put into shapefiles or digitize was human context, was culture, which also really affects and shapes a lot of these behaviors. So we were missing out almost as a blind spot some human activities, past and present in this work. And we need something more dynamic. Something that became at least apparent for me as a movement ecologist as well is we need to consider not just night lights or land use change. We need to consider the dynamic nature. For example, what this whale in Chile is experiencing is an army of fishing vessels navigating left and right, which sounds pretty stressful. But also disentangle the effects of what human culture has to do or what past and present human activities um, lead to the collection of biodiversity. So the bigger question is actually biodiversity information by whom, where, when, and why. For example, this is a really interesting study that shows that there's a disproportionate um, composition of people who identify as white when bird watching compared to the average population background of the United States. Um, Furthermore, colonial history there's understanding of both our fossil records, but also invasive plant species carry legacies of colonialism. So there's been really interesting work in the plant world linking the colonialism in different countries with the path navigation on how non-native species were distributed. And also, for example, why on earth are there more species named after Europeans in Peru than all of Europe together? So I would like to think that our field is moving towards that direction. But then I was like many of you, I was I think a second year PhD student, and a lot of different life events happened that led me to want to breach and broaden my scope and what I wanted to achieve on my PhD. We had a global pandemic that affected all of our lives. We had Black Lives Matter movements across first the United States and across the world. And then I also just faced some personal challenges that also changed what I want to do with my science and whether I just want to pursue science or also pursue something that bridges between basic and applied world or communicate science to a broader public or the next generation. And then I read this paper from Chris Shell that I'm sure some of you have read that left me thinking. And I was, first of all, I thought this is really compelling and also a very strong paper. But what was really interesting in this paper too is it was a really strong primer on how um, civic engagement and segregation and inequality trickle to almost every aspect of our cities and our environment. And if we read this graph, for example, from bottom to top, we can see that systemic biases of humans can lead to structural racism and classism, such as residential segregation, which I'll be talking about in a little bit later, gentrification, resource allocation. And this leads, for example, to different zoning policies, which affect urban heat island and green spaces in cities, which is a big topic right now, which further affects how environmental pollutants are distributed, which further affects how disease spread. And these green spaces and all these other layers also affect ecological and evolutionary patterns. And this paper is a really interesting because it's linking civil rights, environmental justice, urban conservation, and social justice as this holistic lens. And normally, as an ecologist, I would be exploring mostly the top part of this pie. And something that with a group of people we became interested in 2021 was to look at the influence of systemic segregation and systemic racism on our information on bird biodiversity. And for that, we use redlining in the United States as an example, because these maps were made available during that year by the Mapping Inequality project from the University of Richmond. And here I'm going to say that I'm a non-resident alien of this country talking about systemic racism that happened in 1933. So bear with me as I'm walking through this, because um, I didn't experience a lot of these issues, and I am not from this country, nor has my family directly been affected by these injustices. But between 1933 and 1950, after the Great Depression in the United States, approximately 2.75 million loans were handed out and issued by the Federal Housing Administration in an effort to facilitate the accumulation of intergenerational wealth of United States citizens. The problem with this was that this was an incredibly racist federal practice that led to generations of discrepancy in generational income across the socioeconomic rating in the United States, because these loans to purchase homes, 1.8% of them went to African Americans, even though they represented approximately 10% of the population. And this is a really great book that I highlight if people are interested in the history of redlining. And also, here, redlining was clearly not the first and not the last segregation practice in the United States. There's city-specific discriminatory covenants and others that now historians are actually digitizing actively. But this was one of the larger spatially explicit maps of discrimination that have been digitized and collected, highlighting the values of historians and sociologists in contributing to sustainability planning and having a better understanding of biodiversity, primarily, particularly in cities. But this practice was called redlining because cities were basically split into 4 categories where they were deemed a good investment or a really bad investment to give these loans. And one of the main arguments to see whether something was a bad investment or a good investment was the racial makeup and the pigment of the people living in there. And the classification was from A to D, with A being named a good investment and D a risk investment, where people wouldn't get these loans. And that's why, because this color was called red, it became known as redlining. And I'm just going to read one example to show how blatantly racist a top-down initiative from the federal government actually was. I had just heard about apartheid from South Africa as something similarly. But here in Baltimore, for example, the description of why this neighborhood was not deemed a good investment was an old residential section seriously threatened with Negro encroachment. So you can see how blatant these maps were. And we might say this practice happened in 1933, but if we overlay vacancy homes in Baltimore with redlining maps from the 30s with vacancy plots from nowadays, we can see a very strong overlap. In addition, we also know that redland areas have less income and lower home ownerships, and people living in redlands areas have a shorter life expectancy. There's higher air pollution, higher rates of cancer, and 2021 onwards, there was a lot of movement about environmental facilities and environmental justice explorations of redlining, where it was shown that these areas have more urban heat islands and they have less trees. And after reading Chris Schell's paper, I asked myself, do these areas have less biodiversity or do they have less biodiversity data? Because these things are very different questions with very different answers and implications. So if I have to put 2 books together on my kitchen table, which is what I did to describe this paper, it was this, and we initially pre-printed it. And this is the team of rockstar scientists that facilitated. Dexter Locke, who's a sociologist at the US Forest Service, and Millie Chapman, who's a postdoc at NC's, but at the time was a PhD student at Berkeley. And what we did here is for 195 cities across the United States that had these redlined maps, you can see, for example, New Haven and Detroit. We downloaded basically all information from the Global Biodiversity Information Facility of birds. So the big data aggregation of biodiversity data, and overlaid it on these maps. And we asked, does A, B, C, or D have more data? And what could be some of these patterns that we are seeing? So we downloaded over 12 million bird records from GBIF using, I think it was called our GBIF-R package. And we explored both how race-based zoning relates to the collection of biodiversity data and how this looks after we would account for things that a bird would care about a lot, such as climate, water, tree cover. So the first result, what we found was that consistently per square kilometer, non-redlined areas in A have more than twice as much data than redlined areas across the United States. Um, our second result was that if we are to think about not just how much records we have, because we might have, I don't know, 55,000 records of a blue jay in front of my house, but if we want to think, okay, how saturated is the species accumulation curve? How much knowledge do I think I have in order to make an accurate conservation decisions on bird biodiversity in New Haven? That's measured as completeness. And we can see that our understanding of these local areas in non-redline areas is significantly higher than in redland areas. And what I also did then, I flipped the switch a little bit, the script, and I looked at which areas in the United States, in these urban areas, are places where if we were to birdwatch there, we would have the highest information gain. And I call these places cold spots, biodiversity cold spots. And we see that C and D have more biodiversity cold spots than A. And here a caveat of this metric was that I needed at least 5 points per polygon to calculate cold spots. So D would actually be way higher because most polygons without any bird records are in D neighborhoods. And just to show how blatant this is in New Haven, A6 is where my office is. That's right next to Yale Peabody. Lots of green spaces, really nice campus. If I take 300 meters, two traffic lights, past some really great food carts to the right, I would be arriving in Dixwell neighborhood, which is a highly segregated neighborhood, which was redlined in 1933, which is very close to my campus. I would see that while my building, Osborne Memorial Laboratory, has approximately 3,000 bird records per square kilometer in that area, Dixwell has 33. And we registered 109 bird species around this place of campus. And no one can tell me that some of these species don't fly 900 feet as the crow flies to D4 and use that same airspace. So this is could be something of concern that especially grassroots organizations that teach K-12 STEM should really take into account, and where we're collecting data and how that's amplifying in the age of digital information. And a lot of you might be thinking, well, we know that non-redline neighborhoods have more tree cover. What you can see here is the predicted sampling density in some sort of GLM after accounting for green space, land cover, climate, population density. So there's still orders of magnitude difference where we collect biodiversity data, even after accounting for all the things that would also impact biodiversity. And then a reviewer asked us, well, could you compare these trends from temporally? So we did. We looked at what is the accumulated sampling density in square kilometer across A, B, C, and D in the last 20 years, which reflect the age of digital information, right? So GBIF is doubling every 2 years, I think, approximately. MoveBank, which is a database on animal movement, is also doubling every couple of years. So in the age of AI and automatic sensor detector, and I'm sure some of you have amazing tools that generate all these different information, these discrepancies are actually getting worse over time, with discrepancies in where we collect biodiversity data across wetland areas and urban neighborhoods getting 40% more unequal. So I think this is a striking result that shows that we need to take actions right now as well, actually, to close this gap in an environmental just way. Because the last thing that we should do actually is just bird watching these cold spots. We need to promote financial incentives and opportunity through federal and state policy that links environmental justice and conservation to fund participatory research campaigns, which I think could have a lot of added benefits besides biodiversity gain, such as mental health benefits, getting outside, psychological benefits, and even music production, like you'll see later. Another reviewer mentioned, well, this pattern, you can see it is because eBird is super biased. This is probably because participatory science, or citizen science, like called by some, is driving everything. The cool thing is with GBIF, we have the metadata information, so we can actually track that. So what we see here is that eBird and others being mostly museums across these 195 cities, are actually fairly biased, while iNaturalist has a little bit less, and the average demographic of iNaturalist is significantly younger. I'm sort of doing like a data trick here, because if you look at the y-axis, most data still come from eBird. So iNaturalist is actually fairly negligible for birds. But nevertheless, really interesting to start, at least to me. I'm super biased because I wrote it, but like to start looking at who's collecting this data, not just when and where, but who and what type of organizations. And we could even take this one step further and think if NGOs are pledging equity and placing environmental justice at their core, now we could track this through time to see if they're actually making due to their pledges. But we could think, what about all of the other biodiversity of the planet? Well, that's a very fair point, because the other facets of biodiversity, sorry, if we think about it, birds have 10,000 species of the world. There's like 1.2 million described species, so it's like less than 1%. However, over 50% of all data on GBIF, this pie chart represents the global percent of number of biodiversity records on this database. More than half of all records are birds of all our species in the world, which still blows my mind sometimes. But nevertheless, I'm going to walk you through some of these ongoing results, where we try to expand from redlining to current areas. So we also try to see, we're trying to develop methods that could account for gentrification. For example, in New Haven, a redlined area that is extremely gentrified called Worcester Square could be driving and leading to misleading inferences in the study that we made. And actually the discrepancies are much larger. And I would say that it's striking that we found such big differences in where we collect data, even without accounting for gentrification. So the problem is even worse. So we're trying to incorporate different sections of urban areas, metropolitan statistical areas, and redlining maps, which will allow us to also provide some temporally explicit, almost like evolution of these things, because cities changed in time and shape all the time. I didn't know any of this. I just learned from Dexter Locke by working with a sociologist who's basically working on the R package tidy census. But we're following up the bird study with every single taxa we could see on GWIF. And these are the 195 cities again. I actually believe we have a few more because more maps were digitized since then. And this is just what a metropolitan statistical area of San Diego looks like, the urban area of San Diego, and what the redlining maps of San Diego look like. So you can see the city grew. And I'm just still wrapping my head around what all of these cities things mean, because I'm by no means an expert, but I'm very interested in learning, because I think cities are this interesting intersection of science, but also where people take decisions based on emotions. And there's a lot of momentum, political momentum you can grab that hopefully I can show with some music and leverage technology. But following Chris Schell's prediction, that would say that across cities, there might be or there might not be differences in species richness across redlining rates. First, this is how the amount of biodiversity data across the entire tree of life for 195 cities in the United States looks like. And I think what's interesting too is in urban ecology, a lot of times people are saying cross taxa and cross city comparison are knowledge gaps. So through data mining, caveat being none of this data is collected by us, we can see that consistently for amphibians, birds, fungi, insects, mammals, plants, and reptiles, there's more data being collected in A than in redline neighborhoods. So this kind of like follows the same pattern than the bird paper, that you will quickly see in the next bar plots that the bird paper actually led to some inferences that doesn't apply to the rest of tree of life, which is super interesting. If we think at estimated survey completeness, how much do we know? We can see in birds, again, this very clear pattern with significant differences between non-redline areas A, there's higher survey completeness than D. Here we can see that a lot of these results are non-significant. In fact, only plants and birds are significantly different in where we collect biodiversity data. Mammals barely so, not even insects. So this clearly caught us by surprise. And then when calculating expected richness, here with a massive caveat that since we have so little data on insects and plants, our expected richness is super low by default. That's just an artifact of our sampling methodology. But I think the relative differences between A, B, C, and D is what's interesting in richness. We can see that actually there's only significant number of expected species richness in birds than in the rest of the tree of life. So I'm really glad we did this study, because it showed that not all data is birds, which is obvious, but also not at the same time when I was looking at these results at first. And what's interesting is that one of Chris Schell's PhD students, Cesar Estienne, published a preprint on using just iNaturalist data for 8 cities in California. So using a small subset of the data we're using and seeing a very similar result of expected richness not having more species in A than in D for any taxa except birds. So that's kind of neat because it's two different groups using different data, finding similar results, which would increase the scientific resilience of these findings. Um, and now this recently just rejected paper that I now need to rewrite and submit somewhere else, or like rewrite the cover letter, shows that if we start looking at where we collect biodiversity data, say we're looking at where all GBIF records of a mosquito are in Texas, and I look at what is the income distribution on where these records are compared to what's the income of all of Texas. All of Texas here is going to be white, and all of the mosquito data is going to be blue. So we can see that the average mosquito record in Texas falls at approximately 100,000 median household income neighborhoods, which is significantly higher than the median household income of Texas. The two dashed lines are the poverty line and the mean household income. So we can also see that while a substantial portion of Texans live below the poverty line, that little white below the leftmost dashed line, there's almost no mosquito records in areas of the where the most deadly animal on earth for humans, mosquitoes, might be. And in addition, for example, Texas is a fairly diverse demographic state. If we look at the white line, the x-axis going from 0% identifying as white to people within a census block group, so within a neighborhood identifying as white. So we have a lot of proportion of Texas where people do not identify as white, and that's exactly the opposite of what we see in the curve of the mosquito data in GBIF. So most mosquito data is collected in neighborhoods that have 75% white and up, and almost no mosquito records are in areas that are below 25% people identifying as white. And in the next slide, I also want to show how this could even be a problem affecting species inference, because this could represent a huge social justice, environmental justice, public health concern. But if I were to look at what is the environmental niche of Texas, so what's the precipitation and temperature space of all of Texas compared to what's the temperature and precipitation space of mosquito data in Texas, we can see that a substantial amount of the environmental niche of Texas doesn't have mosquito records. And a lot of these areas actually do have mosquito records. There's a lot of public health literature or papers showing that mosquitoes use microclimates in cities such as plastic bottles with water. So actually blue should be very similar to gray, but this might not be the case because of sampling bias. And then I did it for two more species that might be interesting, such as the spotted lanternfly, an invasive species, where we see as well blue in the leftmost frequency plot is higher than white. So biodiversity records are located in wealthy areas. The middle frequency density histogram, which says there's an overrepresentation of where we collect biodiversity data in places where people identifying as white live. And what's interesting in the right is, despite us not sampling a lot in areas where people do not identify as white, the environmental niche space is still covered. And we can do the same with monarch butterfly in California. So this also brings into highlights that we need to incorporate these socioeconomic biases behind the collection of not just past, but also current digital information. If all of our federal policies centering equity and conservation and justice in one umbrella, we actually need to interrogate that data that way. We just had a paper accepted in Science that is sort of the same pitch, but at the global scale, that if we are at the Montreal Calming Agreement, that we should actually take this into account, particularly income. Here we can see all of the GBIF data again at the global scale. And on the right side, we can log scale income by GDP of countries. And we can see that in the last couple of years, there's all these very, very steep increases where we collect biodiversity data. And there's almost half an order of magnitude of difference. And most of the biodiversity rich countries on Earth are not where we have most of the biodiversity data clearly. But we can also see this in the United States as the example of redlining, but we can also start disentangling human context and when biodiversity data was collected. For example, we can see a big gap during the Cambodia-Vietnamese War, or in panel E, we can see who collected data before 1960 in Nigeria and who collected it after. So after the independence of Nigeria, we see a large amount of Nigerian scientists and organizations collecting data and submitting it. And probably the purpose of documenting biodiversity was very different for a colonial power, which might have been extractive, or after an independence of a country. And I think this is to highlight the importance of equity and taking social context into account, especially there's talks around a $200 billion incentives of countries for a biodiversity fund, and I spent way too much time counting, okay, how many people could we actually help with that amount of money? With 135 billion, we can actually help. That's the GDP of the 200 billion poorest in the world. And if we actually sum it to 200 billion, that's the GDP of the countries highlighted in yellow. Again, I spent way too much time on this than my PhD, but this shows that a lot of these countries are actually biodiversity rich. And if we don't incorporate socioeconomics into account, conservation will face a lot of hurdles, as many of us know. And $200 billion is also the economy of Greece, which at the same time might not reflect the challenge. And if we look at with the size of the US economy, it's a drop in the bucket. But here I'm going to switch gears a little bit, the last 10 minutes of my talk. And yeah, we're all braver than we believe, we're stronger than we seem, and we're smarter than we think. And instead of going into a climate despair, we can also work on solutions at least at the very local scale for me in New Haven to break the cycle, or I like to say, contribute a grain of sand in an environmental just way of collecting biodiversity data. And that is by putting a keyboard between these two books. And what I mean with this is bring it back to this figure. For the past 3 years, I've been working on a project that has sort of snowballed and is a open-ended exploration, exploratory research on uncovering the hidden lives of animals through music theory and AI. It's just jarring into saying I use what I learned in R and GIS on my PhD and tech and try to do scientific communication, which in my case is music. So, for example, this is a computer simulation of pigeons using ggplot and Viridis color palette, where each individual is a different animal. And we had that in an art exhibit and we called it static art. This is GPS tracking data of pigeons around the University of Oxford. Again, ggplot Viridis, G on point, but we can now communicate. It looks like a painter stroke a pencil. We can look at stickerback fish and we can look at termites. And beyond making these beautiful visualizations that the public might not know, but you're probably like, oh, I know the background on ggplot he's using. We can also turn this into music. And this is in collaboration with Matthew Sutter at the School of Drama. Um, and you're just gonna listen to some stuff now, and maybe I'll just think about what I think while we're listening to this. What we can see, for example, next is we grabbed some GPS tracking data of an animal of these pigeons and made it into a pigeon choir using an electronic music production software. Here, so that's a synthesizer basically. If any of you makes music, the program is called Ableton, and that's the GPS tracking data of these animals. That was data generated by 8 termites, where we basically used computer vision on a GoPro mounted on that Petri dish that allowed us to identify the lat, long, and time of 8 termites that we then translate into music using Python code for data sonification that creates something called MIDI file, which is just electronic musical chords. And then I literally just drag and drop them into GarageBand, and the termites made all of this music, and it sounds pretty nice. Last but not least, this is Flex Tower music. So this is a rice paddy Flex Tower in Arkansas. And I just mapped 4 columns of Excel into a string quartet with Matthew. And what's really cool about this one, it goes forever, but also that's the farmer of that rice field. And this farmer plays the mandolin. So this farmer wants to play with his rice paddy at some point, which was amazing. I would have never thought. But how does this work? Well, we can use AI to track with computer vision. This, I think it's called Tractor. It's a Python package that gives you an Excel sheet that then we can put into Python that makes MIDI files and creates files, which is amazing, but it needs a little bit of programming. But what we also did, I think 2 years ago, we grabbed a Raspberry Pi and some audio moth, and I put BirdNet, which is a soundscape bird identification AI, on a Raspberry Pi, and I bought a $9 microphone. The point was to make it as cheap as possible, and dropped it on an urban farm during bird migration. And what's cool there is we did it with some students, and they learned a lot about AI and biodiversity, and we did it on a social justice angle as well. And we detected 60 species over a 4-week period and logged 20,000 bird records. So significantly increasing the coverage of bird biodiversity in that area. But to like local kids, I would say this is a bird spy microphone that detects who's living in your farm. And we can say something like, oh, the blue jay is the loudest bird. And this is what the data looks like. So it's legit information. And I was lucky enough to win an art exhibition contest at Yale on fancy building. And they asked me, I called the exhibition called Collective Pulse, and they asked me if I could send them a image of my description of the art exhibit. And I sent them this, and they were very underwhelmed. I had never done an art exhibit, so this was my PowerPoint of where would there be live music, where's art. I wanted a fish tank in the middle, and environmental security at Yale said like absolutely no, which is fine. But then this building kind of looks like a fish tank, so I called it a fish tank, and I still got a fish tank. But what we can see here is we can see someone playing a bird sound on his phone, and there's a Raspberry Pi on the table. So this person, they would see in real time what bird ID would be identified by the AI, therefore teaching the public about AI. We have the termite music in the background on the TV. There were headphones connected so people can listen. And there was a little SciComm poster about the Yale Farm singing a song, which is now on Spotify, actually, if you want to smash that like button. Uh, and that is basically a collection of chicken, birds, ambulances, and like one piano, just to make it like a bring it back to the human exploration of the urban sounds in our day-to-day busy lives. We also launched a local art contest, and because it was in Spanish, we had a lot of participation. We had some incredible winners. Lilian Delgado from 6th grade made like all birds of Connecticut. Or in the third place, Alina Zhang's parents sent me like 10 pictures on how this 3D chicken was built. These are all the honorable mentions. We had local artists participate in an art exhibition. We had a local cancer hospital build origami paper cranes because it was a collective animal music exhibition. But the story there that I'm probably butchering is that if in Japan, if you make 1,000 of these cranes, you shall have good health and fortune. And even some cancer survivors made some rocks connecting emotions and nature. And through this experience, I feel like we can often engage the larger public, not just through empirical evidence, which has shown a mixed success, which is also extremely important, obviously, but people also make a lot of decisions based on emotions. You don't get someone to donate to a cancer hospital maybe just based on harder facts, but if someone in your family is going through some of these experiences, that's what often makes people take these very big needles. And I think as ecologists, environmental scientists, evolutionary biologists, we can communicate the lives of nature and their stories in ways that the majority of the public doesn't know. And these new technological tools and data-viz tools that we have, I think wrapped and managed and combined with these holistic lenses can make a positive impression that is environmental justice centered and environmental education. At least that's what I believe, and that's what I'm trying to do. Here you can see how the art exhibit came together. We even played some music. That's basically a machine where each button played a bird from East Rock Park from our local neighborhood. Um, an architect reached out to me after this exhibit and made this piece of art out of the termite data, which I have no idea how they made it. They also made this piece that's now at the Yale Center for Collaborative Arts and Media as a permanent installation called Homologies, based on the termite data. Don't ask me how they did it. We were lucky enough to play at a legit electronic music festival with Sylvan Esso actually in 2022 with our weird music. That's Matthew and I playing at Slingshot in Durham, California. And we downloaded Flux Tower from Durham just to tell ravers like, hey, listen to your trees. They're breathing. So we opened like the local festival there with tree music and added beats to it. And yeah, so we called this tree music. And after that, it was like a legit rave, but communicating nature in a way that I hadn't done before. And I'm lucky enough that in October I went again, and this was the flyer, and this time it was bird music. And then I came back to New Haven, and the School of Management has this beautiful building with these tall windows that shreds all of these birds. So the Yale Divinity School students reached out to me and see if I could give them the spectrogram so that they could show management about all the voices that their building is extinguishing. And this actually led to a collaboration with the Yale graduates religious study and ecology. And I'm actually later today, I'm going to a workshop there. I'm hosting a workshop with religious leaders to see how we as scientists could engage participatory science campaigns such as bird watching, listening to birds with religious leaders across New Haven, because they are serving a lot of these underserved minorities that at least academics or scientists in my city, including myself, haven't done the best job in reaching. And this is the Graduate Conference in Religion and Ecology. We've also engaged with local partners called Pathway to Science, where we now teach how to turn bird songs into music in like a 1 hour module for K-12 STEM education. And this is how it's looking like. So for example, here some kids are learning how to make plant music and tree music. And we talk about why it's messed up that there's no data where they live. And actually the University of St. Thomas, right next to your home, is spearheading this effort as part of an NSF RCN. And most of these partner institutions are actually PUIs and HBCUs. So that's a very exciting, scalable way of teaching and increasing the scope of teaching biodiversity data in an environmental just friendly and accessible way in terms of cost. And this is just to show that some of these efforts can be done at local scales, but also at national scales. So we presented this as ESA. There was a panel on insect music at the Entomological Society of America. I never thought I would do. University of St. Thomas trying to scale this up across the curriculum of 8 universities, religious groups engaging with us, and now hopefully Uruguay will collaborate, which is where I'm from. And what I'm excited about, you're listening while I'm talking to the song of Made at the Yale Farm with a little video. So that will basically be the deliverable of what we're trying to teach at the University of St. Thomas, where people go to an urban farm, they install a trap camera, learn about that, they install a microphone to learn about bird biodiversity, EJ, biodiversity informatics, how what they collect relates to the global collection, and make a musical heritage. And I was lucky enough to have some features on the press, and this is my grandpa reading about how I say that he was like an inspiration of me being a biologist. Um, and with this, I hope to show that even though the work started in the tropics, we can see and collect and engage with biodiversity information, and EJ at a local school, at a local hospital, at a local farm, and pretty much everywhere. And I want to thank my partners on the left, the science front, and on the right, the music engineering front. And I want to thank all of you for listening.
Awesome. Thank you so much, Diego. That was a really, really fascinating talk. So much cool information in there. Again, if any of you have questions, feel free to drop them in the chat, or if you want to ask aloud, feel free to raise your hand or unmute yourself and ask it directly to Diego.
I'll ask one. So Diego, I loved your talk. I think it's super cool how you're connecting all of these interesting themes and making a difference. I'm curious, when you go into areas that tend to be poor, have less biodiversity data, it's very cool how you're connecting, trying to get them to connect in different ways. Just see the value of nature, using music to speak to a different angle in art and these things. And I'm just curious how it's received and what parts that, because like in one hand, they have these new ways to connect to nature and biodiversity, and the other way, someone could say, well, you're making plants speak. It's abstract, and I'm just curious how it's received. I think it's very cool how you're approaching it from so many different angles.
Yeah, thanks. It's a big question, and I think about that a lot, especially what my role is, given that, like, again, like I'm a non-resident alien in this country, and I'm leaving New Haven, and I'm not gonna be there forever. So I would say that it's really important. I love gardening. So for years, I've been working in community gardens in New Haven, and that was sort of like my into a local community member who were working on nonprofits, on grassroots organizations who have these local networks, these long-term trusts. So most of these facilitation, when I'm saying like, hey, I want to teach, can I teach kids how to collect data with Merlin, then bring it to a studio and make like Blue Jay Bachata. That's extremely hard to logistically get done alone, especially as a grad student, when there's no incentive on our academic success to do any of this. Is extremely hard, especially when there's so little financial incentives, even at Yale, or support to do this sort of stuff. There is small grants, but they often require a tremendous activation energy to get done. I would say the best thing that has happened to me was work with local collaborators, such as an engaged teacher, or like later now at 4:30, I'm going to be talking with a bunch of priests. I don't know anything about United States Catholicism, but these people are reaching the communities that I am not at all, that care deeply about the natural world. So I think I normally don't come in as a scientist. I don't talk about ecology at all. I'm just talking about how cool, what a cool bird I saw there the other day, and then I try to highlight why this information might be important, because I brought this paper on redlining up to a New Haven elder, for example, one of these decision makers of the city. And he was like, Diego, this is, and I was talking about ecosystem services and the mental health effects of bird watching. And this person said, Diego, this is awesome, honestly, super cool, but there's gun violence and people are starving. So like, how does this relate at the end of the day with the limited budget that the city has? So that actually inspired me to follow up with the law school here at Yale on like, what are the legal, political, and economic consequences of biased data? So like, we might be using certain legal instruments, less or more, that might have led to different zoning practices, or there's 2 endangered bird species registered on East Rock Park. It might make it very hard to change any zoning laws in the future, right? The likelihood of an endangered species is extremely low, but I think highlighting that economic investments or management green space restoration could happen with these increased sampling is something that at least that on the longer term when talking, is something that has been catching attention. And the whole music education front, even without mentioning any of the science, they love that, because they're like, okay, my kids are gonna have a good time and fun, and all these other side benefits, learning what Python is, what a Raspberry Pi is, learning about biodiversity. I think that's a big added benefit that for me might be like my big universe, but it might play a smaller role in making that initial link. And once they're hooked, you can start talking about all these bigger ones. And then getting 1 or 2 key students who are engaged, or a teacher, is what has worked for me.
Thanks. That's very helpful and insightful.
Because it's really tricky, right? Like last week I gave a talk to Audubon Portland that just changed their name, and also to Audubon Connecticut that didn't change their name, because I think it's important to talk to everyone about this, regardless of how I feel, based on the work that people are doing on the ground, because finding common interest in nature is something that hopefully can cross sometimes partisan lines and different viewpoints, because I truly believe that people care about nature and about pristine environments that we are surrounded with. So I always try to find common ground and not bring too much of my own agendas, and normally bring in someone from a local community that has the street cred to vouch for you, basically, is something that helps a lot. So wherever I'm moving next, for example, the first thing I'm going to do is find a community garden, but also try to see which local grassroots organization are doing environmental work, environmental justice work, and maybe show up to 1 or 2 meetings of them and not say a word, and learn about them, and then reach out. But again, that takes time.
Can I ask a question? Hi, Diego. We met
Hi
in
there.
Portland.
I remember.
I was so happy to see more of your work after that teaser of an Inspire session. I'm curious what you think. You made a comment at the end about our training and what is valued and what you're gonna get credit for. And I thought about this too, and I'm just wondering, like, I mean, could a PhD be different? Could you have like your music as a chapter of your PhD? Like, why not? Right? Like, I don't know. I'm curious your thoughts about that, because you have such a diverse portfolio And it seems like that's where we should be going in the future, that our scholarship should allow us to showcase all of that.
Yeah, I don't know. So I was just at like Yale's big planetary solution workshop with some provosts just to learn what does big level admin think about these things, because they are ultimately, I think if we want to change the system, we need to change the what constitutes tenure, who's giving money, who's sitting on the boards of who's giving money, like because there might be a discrepancy between like what the movement right now might be versus people giving these big financial incentives, especially in conservation biology. I feel that's changing so much. I'm in a EEB department, so as basic science as it gets. So maybe that's where I might have a very limited view. There's these integrative departments that probably value these things much more. But I've also, I don't know, I think it's doable to turn these things into a prototype. Moving things from a prototype to something that works while trying to graduate is extremely hard. I don't know. I would love some of my more socio-ecological work to be part of my dissertation. I mean, we're writing 2 papers on music theory about how animal collective behavior links to music harmony, and that's like legit science. And I never thought I would do it, but there's some rock star scientists that I can do it with them. So I think as programs, maybe facilitating these weird incubator sessions of different disciplines where we need to like don't allow anyone that works together to sit together and then shuffle everyone every half an hour. A lot of these creative architectural places at least at Yale do that much better than at EEB on getting these people together. I don't know, maybe have I truly don't know. I think just the fact that outreach is still something that my personal opinion is that sometimes a lot of people will encourage it as long as you have it on UCV and you have the checks. But if you actually want to do it consistent, that's like, well, you should finish chapter 2, which is also valid.
If there aren't any other questions, I have a follow-up on your diverse portfolio, because I was blown away throughout the talk of like all these different projects, papers, research, things that you're involved in. I'm just curious, obviously it's different from person to person, but how do you sort of manage all of this from day to day, year to year, and staying involved and on all these different projects at the same time?
Yeah. Well, there's a couple things like like I think I have really great hobbies that take me away from my computer. Like I'm obsessed with gardening and dancing tango randomly and bouldering. So like I can't think during those times, or like I do, but to me that's mindfulness. So that um I am at a private institution where I probably didn't have to teach as much as you. So I probably had a couple hundred hours more of research. So I take that into full account that there's probably a discrepancy in how much teaching we have and ability to do these things. So I've had the luxury of not having to teach that much. Um, I have really, really good collaborators that do very different things. So like I always try to find, now when I'm working on papers, I don't think of it as a paper anymore, but almost like as a research portfolio that like this group of people will take, and like we will change like who's leading stuff so it becomes a thing that has energy and will keep moving. So I have that with my movement ecology world. I have that in my biodiversity EJ world. I have that in my music world. And I think that makes my work much more fun, but I'm also much more of a breadth, not depth type of person, and that's what works for me.
Yeah, thanks. That's super helpful.
But I'm
It
also in
looks
the
like
6th
we're
year of my PhD, right? So like
yeah, it's fair. It looks like we are right at 1 o'clock or noon or 2, depending on where you are calling in from. If anyone wants to stick around, if you have time, we can for more questions. But that is the end of our seminar. If not, I think we might have one in the chat. Diego, are you able to see the chat?
Just a
yeah,
comment.
If not, I can read.
Yeah,
Just a
no, good
comment.
Oh
to
yeah,
s-
just a comment. Yeah.
Good to see a lot of familiar faces. I see Joseph as well, who I saw in Denmark last, Rebecca at ESA, and John, who's seen some of these polygons in New Haven. Um,
Great. Well, thanks again, everyone, and have a good weekend.
Thanks,
Thank you.
Diego.
Next week.
Bye. Good to see all of you.
Take
Ciao.
care.
Ciao. Likewise.
Ciao, ciao.